This is a video on solving compound inequalities. This is a follow-up to my video on solving linear inequalities. And, the only difference between these ones and what we've seen before is that these are inequalities that are joined by the word and or the word or. So when you see the word and or the word or, it's telling you something specific. So let's talk about what the words mean before we get into the examples. So for an and type problem, so you'll see this between two inequalities, and this means you want the intersection of both solutions. So you'll see the word and between two inequalities, and we want the intersection. Now, when we say intersection, that might not be something you're familiar with. Think of like overlap. So where the solutions overlap, or what they have in common. So when you are looking at a problem, the word and is in between the two inequalities. We're looking for the overlap. We're looking for what they have in common. They call this the intersection. You might see this symbol like this to represent and. It's kind of like an upside down U. You won't use it very often though, because every and type problem usually can be simplified into a simpler notation. For or, right, so the word or in between two inequalities means we want what we call the union. So we want the union of the solutions, all right, or the union of both solutions. When I say the union, what I'm really saying is I want anything that's part of either solution should be included in the answer. So you should think of this as saying anything that is part of either solution should be included. So the words mean different things, so it's important that you pay attention to the words when we're doing these inequality problems. Sometimes people ignore them. And means you want the overlap, the intersection, what they have in common. Or means we want the union. That means you want whatever is part of either solution to be included in your final answer. So let's take a look at a few examples. So if I said to solve, x plus 7 is less than or equal to 9, and 4x minus 3 is greater than negative 7. So essentially you have two linear inequalities here, and they're joined by the word and. Now, when you see a problem, that might not emphasize this, but you should notice this right away. The word and is telling you at the end you want the intersection, you want the overlap of the solutions. So we basically solve these individually, and then we're looking for our answer at the end of the problem. So for the first inequality, x plus 7 less than or equal to 9. To solve for x, remember you want to leave x by itself on one side, so we're going to subtract 7 from each side. End up with x is less than or equal to 9 minus 7, which is 2. And that's the solution for the first part. And we need the solution for the second part, right? So, and whatever we get from here. 4x minus 3 is greater than negative 7. Here we're trying to isolate the x term, so I'll add 3 to each side. End up with 4x is greater than negative 4. And then to solve this, we'll divide each side by 4. And end up with x is greater than negative 1. So we have x is less than or equal to 2, and x is greater than negative 1. So this whole thing is your solution. The word and in between there is telling you that you want the overlap between them. Now we're not done. This is kind of like a temporary solution before we simplify it down to our final answer. Sometimes it's easiest to see this if you draw a number line. So if we took a look at a number line here, let's draw both solutions on the same number line. So I know I'm going to need the value of -1. I know I'll need the value of 2. Make sure you put them in the correct order. Right? So -1 is smaller than 2, so it's to the left of it. And if I said for this first part, x is less than or equal to 2, let's remember how we drew this on a number line. The equal to on there tells you that you put a closed circle on 2 because you're including it. X being less than or equal to, less than means smaller number, so I would shade it to the left. And that'd be just a solution for the first part. And we also want the solution for the second part. X is greater than -1. Well, -1 is not included. There's no equal sign in here, so it's an open circle. And we want to shade this one for x is greater than -1. Greater numbers or bigger numbers are to the right of it. So I would shade it to the right. Now remember what I said. The word and is important. The word and means we want the intersection. We want the overlap. Well, where do these overlap? Well, the solutions, what they have in common is everything from -1, not including -1, up until 2. So the number line that really shows the solution of this problem, I'm going to draw it down here just as the solution, is where the overlap occurs. We have an open circle at -1, we have a closed circle at 2, and we want where the overlap was, which would be in between. So that's what the solution looks like on a number line. But this tells me I can write this in a more compact way than what I have written here, right? X is less than or equal to, and x is greater than -1. What this really shows is that my solution is everything starting at -1 up to 2. The way you write this as, a compound inequality is that the x values are what's in the middle. All the x values that satisfy the original problem are what fall in between. So I could write this starting from left to right as -1 is less than x is less than or equal to 2. Once you have this, that is actually how you want to write the solution. So what we had above was equivalent to this solution, but this is really the way we write it in a more compact form. And now we can still talk about interval notation and set builder notation as well. So for the interval notation, and we're looking at our number line typically, so that means that we would start at -1, and we're not including it, so we're going to have a parenthesis, if you remember how we did this, because we're not including it, we use a parenthesis. We start at -1, and we go, from left to right, up until 2. Closed circle on 2 means we're including it, so you have a bracket there. And so we have the interval notation, parenthesis, -1, up until 2, closed. It means the same thing as our solution we've written above, but we've had to state it in interval notation. If I wanted to write set builder notation, remember how set builder notation works. You always write a curly brace for a set, the variable we're talking about, which is x, the bar, that means such that, and then this -1 is less than x is less than or equal to 2. We're going to write as the condition. So -1 is less than x is less than or equal to 2, and close the curly brace on that side. All right. If this problem was an or problem, so instead of this saying and at the top, if this said or, keep in mind that this would be different than what we did here, right? Or would mean we'd want, the union, and sometimes for union you'll see it, this U symbol. I should have mentioned that earlier. You see it with this U symbol, but the union means, right, anything that is part of either solution should be included. So if this said or, this would be different. Then I'd want everything going this way and everything going that way. It would actually be all real numbers because you want anything that's part of either solution. But in this case for and, you want the overlap, what they have in common. Let's take a look at another example here. If I said to solve (3x minus 6) is less than 12, and -2x plus 4 is greater than or equal to 18. Again, the first thing you should look at here is the word and. And since we have the word and, we know we're going to want the overlap or the intersection of the solutions at the end. We're going to solve them individually. So 3x minus 6 less than 12 means First I want to add 6 to each side to isolate the x term. I have 3x is less than 12 plus 6 is 18. And then solving this, I'll divide by 3 to each side, and I end up with x is less than 6. Now remember, that's the first part of the solution. And, remember, we're using and, make sure you have that word there. We got negative 2x plus 4 is greater than or equal to 18, so I'll subtract 4 from each side to isolate the x term. I end up with negative 2x is greater than or equal to 18 minus 4 is 14. And then we divide by the coefficient here on x, which is negative 2, to isolate x. Remember, when you divide by a negative, this is a special rule that we said, you have to switch the direction of the inequality symbol, right? Because we divided by a negative number here. So we have x's, this becomes less than or equal to 14 divided by negative 2 is negative 7. And so my answer, for now, we're not done with this. We got x is less than 6 and x is less than or equal to negative 7. So, the easiest way to kind of look at where your solution will fall is to kind of look at a number line first, similar to what we did last time. If I was to put these both on a number line, think about what happens here. 6 and negative 7, make sure you put them in the correct order. We got negative 7 here. We've got 6 here. We want x less than 6, so an open circle on 6, because you're not including it, there's no equal sign, and x is less than that would be to the left. Now don't automatically assume the other one goes to the right. Just because the first one did doesn't mean that they all do that. There's no pattern to this. X is less than or equal to negative 7, well, that would be negative 7, closed circle, because we had an equal to. X is less than negative 7, well, that's also to the left, right? Smaller numbers are to the left. And tells me I want the overlap, the intersection. Well, the overlap of these solutions is everything up here until negative 7. So writing a condensed version of this number line, right, my actual answer is where the overlap is. So this part here we're not using. We're really going to go to negative 7. We're going to have a closed circle, and we want everything to the left of it. So this would be my solution on a number line. Keeping in mind that, this here is a way of expressing the solution. This is a way of expressing the solution, but it's not simplified. If I wanted to simplify this, right, how would I write this as just one inequality? Well, this is just all the x values less than negative 7. So the actual solution, the way you want to write it in a simplified form, is x is less than or equal to negative 7, right? The equal to, because you got that closed circle there, all the values to the left of it means it's less than, and this would be the actual solution. If this said or, just to kind of point it out, then you would want anything covered by either of them. So you would want all of this, and you would want to take all of this, because either part is okay, and then you would have all the x's less than 6. Because it says and, you want the overlap. Let's talk interval notation. The interval notation here, we start from left to right. And we're just looking at this number line here, the simplified one. Starting from the left, how far over does it go? Well, it goes to negative infinity, so we need a parenthesis negative infinity, right? Because you never can include it, because negative infinity is not a number you can attain, so it's a parenthesis. And it goes up till negative 7. Closed circle means bracket, because you're including the negative 7. So it's all the x values, to the left of negative 7 and including negative 7. The set builder notation. Remember, set builder starts with a curly brace, always. The variable, which in this case is x. The bar, that means such that. And then the condition, which is our solution here. Make sure you don't write what we had up here. It's really the simplified version. So it's x is less than or equal to negative 7. Alright, so that's solution 2, where these two solutions overlap, the intersection. Let's take a look at a couple OR problems. I said to solve x plus 5 is less than or equal to 4, or negative 3x plus 7 is less than negative 8. First off, key thing to notice right away is that the word or is what we're looking at. Or means you want everything that's part of either of the solutions in your final answer. So if I have x plus 5 is less than or equal to 4, here I will subtract 5 from each side to solve the first inequality. I get x is less than or equal to 4 minus 5, which is negative 1. Or, solving this one, we'll subtract 7 from each side. I have negative 3x is less than negative 8 minus 7 is negative 15. And then we'll divide both sides of this by the coefficient in front of x. So we divide by negative 3, divide by negative 3. We end up with x's. Now remember, this is my rule. If I divide by negative, and it's me dividing by the negative down here. It has nothing to do with the 15 being negative. It has everything to do with me dividing by a negative 3. Then I have to switch the direction of this. So it becomes x is greater than, negative over negative makes this a positive. 15 divided by 3 is 5. So my answer I've got right here is x is less than or equal to negative 1, or x is greater than 5. Or, remember, means we wrote it earlier, but just not to forget, anything that is part of either solution in our final answer. So let's draw a number line for this. So on the number line, make sure you put the values on, negative 1 and 5, make sure you have them in the correct order. We got x is less than or equal to negative 1, so the equal to part of that tells me to put a closed circle. X is less than or equal to negative 1, less than means we want to the left of it. And for the other part, we have x is greater than 5, so open circle on 5 because we're not including 5. X is being greater than 5 and they're larger, so you want to go to the right of it. Alright, so now, or means we want anything that's part of either solution. So really I want all of this and all of this, right? So all of this is the entire solution. And that's my number line for the solution then, because those are the parts that I need. Keeping in mind when you look at this, that this was an and problem. If I was looking for the intersection, these would mean that they need to overlap, and these overlap nowhere. So an answer to something like this, if it said and, would be no solution, and you'd have an empty number line. But for or, like we have here, the whole thing is a solution, right? Anything that's part of either solution you want in your final answer. So this is the number line that goes along with it. We don't have to manipulate it at all because it's already set up how we need it. So how do I write the solution? Well, the way you write the solution, right, based off of this, and based off what you have up here, you can say x is less than or equal to negative 1, right? You can use the word or you can use that union symbol, that U that I showed earlier. Union x is greater than 5. Or you can write the word or here, right? The union means or. So this would be your answer. All right, in interval notation, we want to talk about the interval we see in our number line from left to right. From the far left, well, we need all of this and we need all of this. So everything from the far left, well, we start at what value? We start all the way out with a parenthesis, negative infinity, because it goes out forever to the left. How far up does it go? Well, it goes up to negative 1. You can't count anything in between here, so don't write in between any of these pieces in here, right? You can't count anything in between. So it goes from negative infinity up until negative 1. Since we're including the negative 1, we have a bracket. Because this is a or problem, we know we need the union. So now when you write the interval notation, you should write this U here for the union. It's a symbol, right? And then we start back up, and you ask, okay, where do I start back up? Well, I start back up at 5. Do I include 5 though? It has an open circle, so that means I put a parenthesis, 5, comma, how far to the right does this go? Well, it goes out forever, so to infinity with a parenthesis. Remember, you never include the infinity side with a bracket because that you can never attain infinity. And for the set builder notation, if we're looking at this curly brace for a set, the set of all the variables, the set of all x, because that's our variable that we have here, the bar, that means such that, and then our condition, which in this case just x is less than or equal to negative 1, or x is greater than 5. You can put the union symbol there. Either way is okay. And then close the curly brace, because that's a set. So for an or problem, you want everything that's part of either solution. Now, just because this one came out with both sides, being included like this, doesn't mean all or problems do that. It really depends on the scenario you're in. If you went back to the previous one up here, right, if I was looking for an OR problem on this example, OR on this just means you want everything less than 6, because you'd want all of this, and they already overlap here, so you want everything up until 6. So an OR on this previous example, right, if this didn't say and, it said OR instead, would be x is less than 6. So there's not a pattern involved in these. Sometimes people think it always has to be one way, it always has to be another way. Really pay attention to what you're trying to find. Right, for OR, it's anything that was part of either solution needs to be included in your answer. For AND, it means anything that overlaps between the two solutions is your answer. So that's the difference between intersection, which is AND, and union, which is OR. Let's just take a look at one more example here. If I said to solve 3x plus 2 is greater than 4, or 9x minus 5 is less than or equal to 13. So the first thing I would point out is that you got the word OR, which means you want everything from either solution at the end of the problem. Solving for the first one, we'll subtract 2 from each side to isolate the x term. So we got 3x is greater than 4 minus 2, which is 2. And then divide by the coefficient of x, so divide by 3, divide by 3, you have x is greater than. Leave it as 2/3, don't put a decimal here, because a decimal for this would not be exact, so x is greater than 2/3. Fractions are okay. Or, solving this one, we'll add 5 to each side. We got 9x is less than or equal to 13 plus 5 is 18. And then again, we divide by the coefficient here of 9 to each side in this case. So we have x is less than or equal to 2. So we have an OR problem. X is greater than 2/3, or x is less than or equal to 2. And I would say let's draw, what the number line would look like first, just to get an idea of where our solution would be. So make sure you have the numbers in the correct order. 2/3 is smaller than 2, so 2/3 comes first, 2 comes second. And once you have that, we want x is greater than 2/3. So greater than, there's no equal on it, so it's an open circle on 2/3 because you're not including the 2/3. Greater than means we want things to the right. For the x is less than or equal to 2, we want to include the 2, so closed circle because there's an equal sign. X's that are less than would be to the left. Now, this is where it's important to know if you have an AND or an OR problem. In this case, I have an OR problem. OR means I want everything. So I want everything this way from 2/3. I want everything this way from 2, which means I really want everything on the whole number line. So this number line, if I was to draw it, a little more succinct, means I want everything across the whole thing. So if you were looking at this number line, your actual answer, the solution you would write, is actually shading the whole number line. If you look at solutions for this, you would, because everything to the right of 2/3 works, everything to the left of 2 works, and that means that, when I say this OR, I get all real numbers, and that's actually the solution. So if you're looking at this number line, that's the answer. You're shading the whole thing. It's all real numbers. The way you can write your solution, right? You can actually say in words, all real numbers. You may have also seen another way of writing this would be kind of like an R with this extra bar here. It's like a fancy R. That means all real numbers. These are interchangeable. But it really tells you any real number will make this true. If this was an AND problem, right? So if this said AND instead of OR, AND would be the overlap. Well, AND would be what's in between here. So it would be everything from 2/3, not including 2/3, up until 2. So the word in the problem really matters. And just because it says OR doesn't mean that you automatically have the previous case, right? We don't automatically go opposite ways. That's something that people try to deduce sometimes. It's not true. So this would be all real numbers. If we were going to write this in interval notation, well, my solution really is everything to the left. How far out to the left you go? Well, you go out to negative infinity, so it's parentheses negative infinity. How far to the right you go? Well, you go out to infinity. So it's everything, right? It's all real numbers. Parentheses on the ends because you can never include the negative infinity or the positive infinity. So for interval notation, all real numbers is just negative infinity to positive infinity. It covers all of them. Parentheses on the ends. For the set builder notation, we have the set, curly braces, of all x, because that's the variable, the bar that means such that, and then the way we kind of write this is we say x is a real number, but we write it like this: x is an element of R. That's the fancy R, meaning all real numbers. X is an element of all the real numbers is how you would read this, just to kind of, right, this means element of. We kind of learned this earlier in the course, but may have forgotten. So x is an element of the real numbers, or of the real numbers. So it's just saying x is a real number. So any real number makes the original equation true. So, you know, there's different scenarios that come up depending on if you have and or. You have to pay attention to what you're looking at. And there's scenarios where, you know, if we go back to this previous one, if this was an and problem, the answer would be no solution. So the no solution would be the empty set. There wouldn't be any values that would make it true because there's no overlap in this. But since it was or, we included each piece. So each problem is different. Understanding the difference between what and or mean really do help. And remember is the intersection, which means the overlap. You want what they have in common. Or is the union, which means that you want everything that's part of either solution in your final answer. So hopefully this video helps.